we're going to be learning in 5-4 how to divide polynomials. So remember long division from elementary? I'm hoping that you do, because we are going to use it again, but this time with polynomials instead. So for our first example, use polynomial long division to divide 4x squared plus 23x minus 16. We're going to divide that trinomial by the binomial x plus 5. So we're going to write that as a long division problem first. So you're going to take your divisor, what you're dividing by, and you are literally going to write out a long division problem like we used to in grade school. Okay, and kind of like we did in grade school, we are going to look basically at, I'm going to underline some things right here. We're going to look at the 4x squared, our leading term in our trinomial, and we're going to look at our leading term in our binomial. And that's what we're going to ask ourselves. We're going to say, what do I need, or how many times does x go into 4x squared? So really all you're going to do at this point is you are going to basically say, what do I need to do to this x right here to make it into 4x squared? Well, I need to multiply it by 4, and I need to multiply it by another x. Okay, so there's kind of where we're starting. What I want to also point out is notice, well, we have in our, I'll talk about that in a minute. We have to make sure we have our x squared, our x, and our constant. You have to have every exponent covered, from your leading exponent, from the greatest exponent down to a constant. You have to have it represented in some way. And we have our x squared, we have our x to the first, and we have our constant, which is like our x to the 0. So we have everything covered under the divisor, under the divisibility sign. So now once we've decided how many times x goes into 4x squared, we're going to actually do just like we did in long division. We're going to multiply. We're going to multiply 4x times the x first. So we're going to take the 4x and we're going to multiply it by x. So 4x times x is 4x squared. But then we also have to do the 4x times the positive 5, almost like we're distributing through. So 4x times positive 5 is positive 20x. Okay? And just like the very next step in long division, we are now going to subtract. Okay? The thing is, we're subtracting this entire quantity right here. So that means this negative that out front of the parentheses needs to be distributed all the way through. So my positive 4x squared, just like in long division, I'm subtracting, but my positive 4x squared becomes a negative 4x squared, but also my positive 20x now becomes a negative 20x. I'm going to just kind of carefully erase this stuff. I'm going to have to rewrite the whole negative 20x. But as I distribute that negative through, and you guys are going to have to pay attention to this video, and if you don't understand what I did right here, it's because I'm subtracting everything now. I'm changing the signs of both of my terms. Now I can go ahead and do the actual addition. Well, 4x squared minus 4x squared is 0x squared. That's the whole goal. And then 23x minus 20x is 3x. And again, just like in long division, bring down what's left over to still divide. Now I'm going to ask myself, how many times does x go into 3x? Well, I need to basically multiply that x by a 3 to get the term exactly the same. So 3 times, now I'm going to do the same thing here. 3 times x becomes 3x, and 3 times positive 5 becomes positive 15. Okay? Now, again, I'm subtracting, so they both need to change signs because I've distributed that negative through. I'm not going to show you that again, but I could put parentheses around there. I'm changing the sign of everything, so now I can actually do my subtraction. 3x minus 3x is 0, and negative 16 minus 15 is negative 31. So up here, when I divide, what I actually come up with at the end is my answer basically becomes 4x plus 3 with a remainder of negative 31. Yes, we're going back to remainders. So when you actually divide, you could say 4x squared plus 23x minus 16 divided by x plus 5 equals 4x plus 3 with a remainder of negative 31. There we go. That's division. Let's do the next example. keep doing. We're going to keep practicing so we kind of get through this. So now we're going to say the next example we have is actually just checking factors, but it's still long division. So it's asking me, is x squared plus 1 a factor of 3x to the fourth minus 4x cubed plus 12x squared plus 5? So I'm going to go ahead and write it as a long division problem. So I'm going to actually divide the polynomial with 4 terms divided by x squared plus 1. So I'm going to write this out as a division problem, x squared plus 1, and which is, we're dividing this. Now I'm checking, I've got 3x to the fourth, I've got an x cubed factor or term, I've got an x squared term, but notice I don't have an x term, so I have to put in that 0x. I cannot skip that x when I'm actually dividing, and then I'll put in my constant. I have to have all of my places for the different exponents from largest to smallest. I have to have them accounted for. So now again, my next question is going to be, what do I need to multiply x squared by to get 3x to the fourth? Well, I need to multiply the x squared by 3, and I need to multiply by an x squared. So 3x squared times x squared is 3x to the fourth. And 3x squared times 1 is just 3x squared. Now, I'm subtracting both of those, so I need to change the sign of both of them. And now I can actually subtract and bring down. So 3x to the fourth minus 3x to the fourth, well, those just add to 0. Negative 4x cubed minus 3x squared. That's interesting. So what do I do in this case? Did I have any x cubes? No, I didn't. So see, this is kind of a common thing that might happen. So here I had 0x cubed. Don't forget that step. So when you go to subtract, make sure you have like terms. Very common mistake. I now need to put my 3x squared under the x squared because I have to have like terms. So negative 4x cubed minus 0x cubed becomes negative 4x cubed. 12x squared minus 3x squared. Okay, now that makes sense. So I get positive 9x squared. Okay? Again, let's repeat. How do I get my x squared to become negative 4x cubed? Well, I need to multiply by a negative 4 and 1x. So negative 4x times x squared becomes negative 4x cubed. And negative 4x times 1 becomes negative 4x. But however, look, I'm going to catch it this time. I have 0x squared. Okay? So I can go ahead and I can bring down my 0x. Because I'm going to have negative 4x times 1, which is negative 4x. Now I can subtract. Don't forget, what do I have to do? I'm distributing this negative all the way through. So this becomes positive. My 0, we can put a negative there. And my negative 4x becomes positive as well. Don't forget to distribute that all the way through. You must distribute. Oh, I actually write it out so you can see what I'm doing. You must distribute that negative. Negative 4x cubed, positive 4x cubed adds to 0. 9x squared minus 0 basically becomes my positive 9x squared. And then 0x and 4x is positive 4x. Okay, I'm going to bring down my positive 5, and I'm going to do it one last time. 9x squared, or x squared into 9x squared is going to be positive 9. 9 times x squared is 9x squared. I have 0x this time because there's no x in my divisor. And then 9 times 1 is 9. So again, don't forget to distribute that negative all the way through. So this becomes negative. This becomes negative. My 0 doesn't really matter. It could stay positive. It could be negative. Doesn't matter. 9x squared minus 9x squared. Get rid of that. 4x. And then positive 5 and negative 9 is negative 4. Yes, we can have a remainder that looks like that. So a remainder of 4x minus 4. Okay? Now, I'm asking if this is a factor of this polynomial. Okay? Here's your last step to answer this question. If the remainder is 0, then it is a factor. Well, check out my remainder. So I would answer this question, no, x squared plus 1 is not a factor. If I were to factor that polynomial out, I would not have x squared plus 1 as one of its factors. Okay, so keep that in mind. Make sure you know what it's being asked of you. If it's asking you to check factors, you can do long division, and if the remainder is 0, then it is a fact.